Okay, everybody. Hi, thanks for coming by. My name is Pablo Meier. I was one of the founding engineers of RAMP, so one of the sponsors of the event. Come talk to us after the fact. We're kind of new in making ourselves known, but we're very happy to be here at ElixirConf, very happy to be sponsoring and presenting things we talk about. Yeah, you can read what I write at morepablo.com or some things on Twitter. It's in your Pablo. So the title of my talk is A Tale of Two ORMs, Design Decisions Between SQLAlchemy and Ecto. Just to get a show of hands, how many of you have written Python before? Wow, a lot of you. How many of you have written SQLAlchemy before? Still more than I expected. Awesome. How many of you have written Ecto? Woo! Yeah, all right, cool. Me too. So before we create an apple pie from scratch, we must first invent the universe. So we'll talk a bit about relational DBs as to like the theory behind them and why it can be hard to write an ORM. I'm going to come in hot. I'm going to come in and say that in the entire field of computing, go back to World War II, Alan Turing making machines to break codes, all the way to whatever the pinnacle of computing is now in 2021. I'm going to say Kubernetes because it scares people. But like from this entire period of time, I think that relational DBs are one of the crown jewels of the field. They are just one of the best ideas, implementations, so much work has gone into them. Just relational DBs absolutely rule. And they've survived every revolution we've had in computing. They've survived Moore's Law for 30 years, Moore's Law dying and going distributed. They've survived solid-state drives. Like, we cannot get enough SQL, no matter what we do. We owe kind of the idea of SQL and relations to this guy, Ted Codd, who, not to get all Ken Burns jazzy or Ken Burns documentary where it's like the whole world works one way, then one visionary changed it all. Like this was a lot of work going on at a time, but he's the one most credited with this. He came up with something called kind of the Tuple relational algebra. Basically, it's this sense of like structure, and then you've got these Greek characters because it's very math-like, where you have like the projection, the selection, the rename operator. And credit to someone else for making this great graphic, but it is kind of intuitively what we understand SQL to be. He did this without SQL to reference. He was building something that would become SQL, but it is this notion of relations that you can do operations to that compose very well to get what you need. This is a bit of a different world. There's really only one data type for all these things. It's relations. Even when you do an aggregation, like a sum, you are returning a relation of one element, one tuple. So relations come in, relations come out. Sometimes you take two of them, like in a join. Sometimes you take one, like in a projection. But this is a world of relations. The relations themselves contain tuples, which is the compound data that we work with. Those tuple elements look like primitives as far as most databases are concerned. And the world is expressed declaratively, which is a big change from how we actually write our applications. That's a bit of a problem. We don't usually write our applications as declarative structures. Unless some of you happen to write Prolog. Who here has written Prolog? Who here writes Prolog for their job? Yeah, hands down, right? Like, this is not true. This isn't Prolog that's going to solve SQL by kind of saying what you want SQL to, or Sudoku rather, to look like. We don't write Prolog for our job. We, by the way, and if you add recursion to SQL, you can do some fun things. It is ability to, like, you have the ability to write kind of anything you want. This query, if you put it in Postgres, will print the Mandelbrot set, which is really neat. Yeah, find me after the talk if you want to see this. It takes a long time to run, but it does work. So we could write these things declaratively, but we're not going to do that anytime soon. We kind of live in a world with object-oriented paradigms in some places. We live in a world of distributed systems and implementation details. So it gets a little wild. So often we will get into fights, the Python people and the Elixir people, about like the right way to do things. We'll say imperative, we'll say functional, we'll say imperative, we'll say functional. But then SQL shows up and is kind of like, hi, and it's just going to blow us both back. It's a declarative world of tuples. They come to me and they say like, enlightenment, reaching you. And I'm like, what are you saying? So writing an ORM is challenging. Okay, let's talk a bit about ORMs. What is an ORM? It's going to take these relations and these tuples that we have. So here's just some sample data of a blog post I could write. And when I say ORM, which stands for Object Relational Mapper, it's going to convert these tuples into a more rich compound data structure. So in an object-oriented language, this would be an object. This is an Elixir struct of post and author here. But we want it to do that kind of manual work of converting these things. Do you really need an ORM? If you ask a lot of people who have blogs, no. No, and you shouldn't, you Dirty, no, like this is a terrible idea, it's harmful, it's bad. And they're all kind of saying the same thing. They're saying what I was just pointing out, that it's actually kind of hard to do right, and there's a lot of magic, and maybe if you rely on that magic you don't see on it, then it's a bad idea. So, no. All right, thanks for coming to my talk. No, the truth is, every major application platform ships with an ORM, right? So if they did sync you, these would not be popular, we would not build companies on these. But I've been at like 6 companies, and all 6 companies have had these kinds of massive platforms behind them. So it clearly is not going to sync you. I view it as kind of a reality. You will usually use a featureful ORM. So it's good to think critically again, why it is hard, and what choices those ORMs made in order to get you to where you need to go. To answer the high level question, what is useful to a software developer when working with a relational database? So I'm going to tell you some things about SQLAlchemy. A lot of hands came up. That was really exciting to see, so maybe this will be kind of old hat for some of you. Is it an ORM, or is it a layer over SQL? Are you writing Python-looking SQL, or are you writing objects? Who knows the answer? It's both. Both. It's both. If you look at the reference documentation, they have SQLAlchemy ORM and SQLAlchemy core. So you can write code that uses the object model of Python. You can see that this author inherits from model and post inherits from model. You give it some metadata to tell you what table you're talking to. You declare your fields. And then you can write queries that look like this, which is like, give me a query on author, filter by the name Pablo, pull it out, and then here we're going to join where the author is equal to Pablo on the post. So you can write this. But you can also write something like this, which I'm not showing you what author table is or post table is, but these are other label expressions, but these do not require you to use Python's object system. You don't have to use the extends model or anything like that. You can just kind of write SQL-looking things and return tuples, which is kind of nice. Another thing about ORMs, often means relationships. This is the documentation for how you specify relationships in an ORM in Python. It is one function with a primary argument and this many keyword arguments, and their defaults. So that's a lot of options. And the last thing I'm going to say about SQLAlchemy before kind of moving on the high level stuff is that it's got multiple backends. You can write it for Postgres, you can write it for MySQL, you can use it for SQLite, you can use it for SQL Server, you can use it for Oracle Database. These are the first party supported ones. You have an infinite list of non-third party ones. All this to say that SQLAlchemy follows that very famous Python dictum, there's more than one way to do it. This is a joke. If you're old enough, you remember that this is something Python does not believe. They positioned themselves against Perl by saying, like, Perl said there was more than one way to do it. Python came in like the mid-aughts and says, no, there should be one way to do it. But SQLAlchemy kind of proves otherwise, and this is something we can learn from our ORMs. I'm not trying to knock on SQLAlchemy, is that the realities of our industries are people need a lot of ways to do a lot of things when you become useful enough. Kind of on that note, another fun thing, another reality I've learned about working with SQLAlchemy is what I call the tyranny of integrations. I've worked on 4 companies with this stack. You have Flask, small web development, you don't need too much. SQLAlchemy, it's an ORM. Marshmallow does serialization and PyTest for your test. And all these things do one thing and do one thing well. So what do? We fill it in with a lot of other integrations. Someone conveniently writes you a wrapper for these things. Marshmallow SQLAlchemy, but also Marshmallow Flask and Flask REST Plus, Flask SQLAlchemy, Factory Boy, like all these things have things. So if a bug happens, oh no. Was I too loud? I'll yell. Thank you. So with all these things, if there's a bug, where do you look? Kind of any of these. Stack Overflow. We have a winner. The fun thing about this, I'm not going to tell you which ones, but all of these provide also look for and conditionally import different JSON libraries. So if you're passing JSON between these layers, you get different things. So I call it the tyranny of integrations because these are all useful. It's better to use these than to not use these. But at many of your companies, you'll be like, oh man, you can enter a world of pain. So let's talk about Ecto a little bit. Is it an ORM layer or a SQL layer? I feel like I have more answers to this. It's both, yes, is the other answer. It's both. You can write Ecto queries that look like this, where there's not like a rich object here. You're just saying, give me a table name, give me another table name, and I select a map. This could have been a tuple just as easily. But I could also write something that allows me to use the closest thing we have to an object, which is a schema, and then query it like this. But there is a funny tyranny of integrations thing happening here too, but it's a little different one, and I like this one because it tells me something about the Elixir language itself. We know that schemas right now have this great macro, and it defines a struct that has all this cool database functionality enabled. Who here has used type struct? Has anyone used type struct? All right. This is a really fun Elixir library, which looks at the fact that many def structs you'd like to do have a few different properties more than the raw def struct. You can enforce certain keys and say like, okay, this must always be true. And you also sometimes want to put a type spec and say like, I'm going to define a type T that is my module. So type struct lets you, with this macro, put all that in one definition. It's kind of nice. Who here has used X constructor? Anybody? Okay. X constructor is another cute little macro that says you want to be able to handle string field names or atom field names and be able to create a version of this. What is the problem with these three if you want to use all three? Yes, you have to yourself manage them together. The answer was you have to integrate them together. You can't just declare all three because you're allowed one structure in every module in Elixir. And all three of these are macros around def struct. So you can't really easily say, I want a schema that I also create a type T for that also has these very convenient methods added to it. So in a way, the intersection of these is an exclusion rather than SQLAlchemy, where it's just a big OR of all these other spaces in between and hard to figure out what to do next. So I call this like an interesting fact of working in this one. Okay, now we're going to talk about the topics. We're going to talk about exactly how they do things a little differently. So topic 1, how do we touch the DB differently in both of these ORMs? Let me introduce you to the session. SQLAlchemy as a whole likes to do things as like you're working with instances. So my examples are post, author, comment. You can imagine a world where I have some post objects, some author objects, and some comment objects. And they're all like working happily. It's just like working in object-oriented Python. Very cool. But I see that there's a thread between them. And if I walk toward that thread, oh God, it's the Minotaur. Session is kind of the big thing that you need to learn if you want to use SQLAlchemy effectively. And what is this? It is a large global object, mutable, that handles all your DB connections, and it is referenced by every one of your entities. So it does a lot of things for you. It manages the DB connections, all instances of ORM models, if you have posts, comments, blogs, authors, managed by the session. It will run queries as needed and update things as needed. So you might ask, how do I get the session? Like, how do I get a session that works? It's just the session. Python is great because it's allowing one thing to happen at a time. If you've ever used Flask, sometimes you want to get the web request and you didn't pass it in, like you would pass a plug or a con. So how do you get the request? You import it at the top level. You get the request. Because at any point in the execution, there's only one request happening. It's Python. And it's the same thing going on with the DB session. There's only one session alive at any given point because it's Python. So you need the session, you get the session, and you speak to it. From an API perspective, though, the session tries to handle as much for you as possible. So what does this look like? I'm going to run this thing that says DB query on a blog post, and I'm going to get the post ID, and I'm going to pull 1. This executes it, and now this is a post object. So this post had comments. A funny thing is, by default, if you don't specify a different join strategy, it will do a lazy one. So when you call for comment in post comments, if you didn't specify differently, there's a SQL query happening here that you didn't see. And then we do things with those comments and mark them as red. Who sees where this is going? What if I want to do this? What if I want to say get all the posts and then find spam and the comments? We're now doing n calls to the DB with the default relationship loading strategy. So sometimes queries can happen when you didn't mean to. In fact, literally 3 days before this talk, I was looking at my friend's Python code, and I saw this, which was we're going to create this query object, and then we're going to get like the title for each post in the query. But you'll notice I didn't execute this query. But the query object knows when it's in a comprehension like this and will execute it at this point. You never said actually run it, but it knew that's what you wanted to do, right? So we have another SQL query happening here as it makes this happen. Ecto's a little bit different. It is repo or nothing. So you run this macro to create this query object, and then you must call repo.all, repo.1, or repo.something else. And if you didn't touch the repo module, it just never happened. So this is a design difference. On one hand, SQLAlchemy is like kind of try and figure out what you want to do, and often try and make a default of if you didn't need those comments, you never fetched them. And if you did need them, you fetched them at the time. Yes? That was the punchline for the whole talk. Okay. If you're on YouTube, you didn't hear that. But that's absolutely true. This is an explicit call out. I'll think of another punchline as well. Yes, topics as relationships. How do we specify relationships? I showed you that really funny function signature, but the truth is relationships are the heart of why ORMs are hard no matter what you do, because that declarative composable model. So it's going to be messy in whatever you do. I have to look up put change and whatever it is on Ecto every time I use it. So relationships are hard. SQLAlchemy lets you define your relationship at the model. This is some of that SQLAlchemy code I showed you earlier. And here in the relationship, I'm giving it the join strategy that I want. So the default one, when you don't specify, was what I said earlier. It's this one select. Whoops, where's my little laser? I think I'm dead. It's this one select. And select will just call it when you need it as you access it. Whereas lazy joined will say that we'll join at the moment the query happens. Lazy raised is my favorite. This means that if you try and access this, it just throws an error. It's a bit like preload, which we'll get to in a moment. So yeah, what you can do then is that at query time, you can override these. You can say options lazy load post.comments. And what this means is that before post.comments got described as please join at the time of the query, but in this specific query, I want you to be lazy about it and do it after the fact. So you have the ability to override at a query. Can this go wrong? Yes, of course it can, because we're in a computer conference. What can go wrong? You can specify that you want things to always join at the model level, and then you can put an A calls a B, always join, B calls a C, always join, C joins a D, always call. And then if you query a few A's, you might get surprised to find a massive tree, especially if many of those are one-to-many, of everything you could ever want. Again, you can, but you don't have to specify what you want at the query. Ecto's a little bit different. Ecto does let you say belongs to and has many, but it does not specify a join strategy. It does give you join things that you need if you need to pass through for a many-to-many table, but it doesn't tell you now load it every time. It really only lets you call it here at this point. So if I call this, which is say get me a post, and then pull out the author first name, we all know what this looks like. That's a repo, it's a preload error. We now have to tell it explicitly at query time, either in the query definition or in the repo call, that we need to pull it together and how we join. So it's explicit every time, as pointed out. So it's always per query. Another topic, how do we express a change in these languages? As I mentioned before, SQLAlchemy has the session and the instances, and so it tries to make this as natural as possible. For some context, Python first came out in 1995. Object orientation was all the rage. That's how we were going to scale our software and do everything right. So the idea of looking like classical object-oriented software development was like a good idea. So in order to do this, if you want to change the title of this post, you just set it with a normal mutation assignment, and then the session tracks that. And when you tell the session to commit later, it has all its track changes and pushes them up. Again, that Minotaur, you know how it works. You can kind of predict what it does. Ecto, we know, is a little bit different. Ecto has a set of change sets, and so I'm going to get this post, and then I'm going to wrap it in a change set, and this is no longer a post. This is no longer a first-party entity, and I can't use it naturally like a post. I now have a change set, which carries with it the modifications like the title, Better Living Through Mechanical Keyboards. Graphically, SQLAlchemy has the instance wrapping its own changes, and Ecto has its changes wrapping around the instance. So the instance is still there. You could fish it out if you need to, but this is how we express changes most idiomatically. And from here, you can do validations different ways. We know about validations on Ecto, or many of us do, where you can have the module define validations on the change set itself, and you can compare against them in your test cases, so you don't have to hit the database whenever you kind of mock out your test. SQLAlchemy does also have validations that it allows, but you can also raise an exception on these assertions. It's a high-level view on how they look at changes. Lastly, migrations and the data definition language. Who knows how SQLAlchemy does migrations? There are 0 ways to do it. This is really tongue-in-cheek, actually. Actually, it's kind of true, but there is no way to do it technically. You need to use another project called Alembic. And Alembic, it looks like it got folded in, but it has a very different vocabulary, a very different set of config files and ways to talk to it. But Alembic, according to its documentation, is a lightweight database migration tool for usage with SQLAlchemy database toolkit. It's also in the SQLAlchemy umbrella project, so at this point it is so standardized it might as well be a part of SQLAlchemy. Though if you look at the special thanks and front matter, it says it's developed by this person and loosely associated with the SQLAlchemy project. So it seems to have began life in a different way and then kind of merged its way in. But these migrations and data definition have a different set of primitives, languages, and things you import before you run them. Ecto does give you the full data definition language. I've opened this page on devhints.io hundreds of times, every time, and it tells me what I need to know. So it gives you a data definition language, but it also lets you pull in the repo. So you're able to look at this and say, like, I can do arbitrary code from Elixir. This has led to a few footguns of its own. Who was here at Adam's talk yesterday on pattern matching? Anybody? Yeah. This happened to me when I was working on the Pleroma open source project. Suppose you are building something and you have, at this point in time, you create a migration X with a version of one of your structs, a person version. And you pull in the repo version and then you run it. If you're already at this point in the database, this migration will pass, and if the present looks like this. You continue developing your application. You work and work, you add more migrations, and incrementally, production was here when you moved it, and so were you. You increment, and now person looks different. I had to clone this Git repo and run it entirely. But it died here because person was being pulled from this point in time when this migration was written expecting person to be from this point of time. Like Adam's talk, we got hit by the representation of this. So I find it useful that you can pull in all your data definitions and things like that, but there is a footgun to be aware of when you do this. So to recap a few of the major different ways of doing things, Ecto prefers to be explicit on a lot of things, relationship loading, and like join strategies. When you call the database explicitly, it has to happen a certain way. It tends to give you the data definition language, whereas the other doesn't. And generally, building ORMs is a bit challenging. But I gave the version of this talk and to my partner, and she was like, "Why are you telling this talk?" And I was like, "Because I think it's interesting. I was working on both stacks, and it seemed really interesting." She goes, "No, you got to take a stand. You got to have a point of view. Like, people don't care about this stuff for its own reasons." I was like, "I do." But like, I get what they're saying. Investment and personality matters. So now is like the point for just my like opinion, man. It's not hard to guess also because I'm speaking at ElixirConf. So I do have opinions about this, and I'll say on the whole I prefer Ecto. And I'll talk about why. But first I want a disclaimer to anyone watching on YouTube or anything else like that. I love SQLAlchemy too. I think it's a feat of engineering. I think the people who worked on SQLAlchemy have done more to create value for other developers than I probably will in my lifetime. I think it is awesome, awesome, awesome. So I love SQLAlchemy. But I prefer Ecto. And I wrote a blog post about why I brought Elixir to ramp and what I thought about it. And I think something I wrote there is something kind of applies to the Ecto way of looking at things. I said, a bit of a hot take, I think most dynamic languages are a poor fit for startups who have intentions of being long-term businesses. You've created an environment that's optimized for your founding engineers to build something quickly in the first 7 months. And you set up a set of recurring obstacles that everyone else pays down for the next 7 years. I've been at stage Series B, C, H. I've been a lot of places and the first employee. And I've found that a lot of my job in the later stages is working past things I can't understand. People fight about static and dynamic types, but I think it's not controversial to say invariants help you reason about software, and most dynamic languages don't give you many invariants. So with that in mind, when I think about the explicit nature of where database queries happen or explicit nature of how things join, it seems a little less convenient at first because it's not going to just derive what you want. But over those 7 years where queries get thrown in and out all the time, I find this to be very valuable. And so I like the design decisions of Ecto because normally I know what is happening. I went faster than my normal runs on this, so I just want to say big thanks. Yeah. The question is, did we put policies in place to avoid the migration struct issue? Not formal ones. We're still kind of small and quick enough, and we don't pull in the dynamic definitions as often. Most of our migrations are just pure DDL at this point. But will be something to keep in mind. Yes? Question is, where do you put the validations in the Ecto modules, especially for like 7-year time frames? Our Elixir's pretty new because the company itself is 2 years old, so we haven't really had an issue with that. I have really loved and found value in change sets themselves and being able to create different sets of validations for different cases as you go into the same struct. I found that cool. And I imagine the context is also a fine place depending on where you would go, but I think the module itself has been fine for us so far. Yes?
Just to provide a potential solution for that migration issue, what I do is Ecto actually has a mixed task that will dump the database structure. And so you kind of create this snapshot in time of all your migrations that have run. And then every time you migrate and you reset the database, you just start from that structure file and then apply everything new from that point. And then you never have to run past migrations, but you can still keep them in your repo as this file.
That's awesome. I didn't know about that. Worth? Yeah. He was describing the mixed task to dump your current state of the DB so you don't have to run migrations sequentially, but keep them in the repo. That's awesome. I didn't know that. Yeah. No, no. I haven't worked directly with the Django ORM. I understand there's a lot of like string parsing it does to figure out what you meant when you pass in a string. I love stringly typed code as much as anybody, but that scares me, if that's correct. But I haven't worked with it full on. Interesting. Interesting. Cool. Yes. Oh, that's a great question. What do I miss in SQLAlchemy that's not in Ecto? Sorry, I'm getting some chuckles for that because I don't have an immediate answer. I don't know. I mean, I think actually Ecto has great documentation, but I also like the SQLAlchemy documentation very strongly, and it's got like there's that like that view of like the 4 types of documentations: tutorials, references, like guides or whatever. There is just so much material out there for SQLAlchemy that if you want to, no matter what your preferred way in, I love Elixir's documentation culture, but it just hasn't had so many hundreds of bodies trample over like every road you could want to go on. So that's one thing that I miss when I wanted to. Yes?
One of the things that you could absolutely miss from SQLAlchemy that we don't have an Ecto is global interpreter lock.
Yeah. Too real. Yeah. For anyone watching the video, you might miss the global interpreter lock. That was good. Anyone else? Awesome. Thanks so much.